Here are your solutions to homework 5.3 tonight. Free response question from 2021, the actual one that was used 2 years ago. So again, familiar question, we have a table. So we are going to be expected to either find the slope using 2 points or area, maybe Riemann sum or trapezoidal sum, we'll see. So part A, use the data to estimate the derivative at 2.25. So that's in between here. So these are the points we're going to use. So press pause, see if you can do it first. So for part A, for that, and we should always write down what we're doing. So it's the derivative at 2.25 equals. And then it's y2 minus y1. We don't need to simplify this. And you get 2 points. Is there units involved? Using correct units. So when you take the derivative of a rate, it's going to be centimeters per milligram squared per. So you get a point for this. Per square centimeter per square meter. So it's milligrams per square centimeter in terms of the rate. That's how I would write it. Meters, I'm trying to look at the answer key, how they write it. Distance of, and then what does that mean? So if we read the sentence, the rate is the density of bacteria population. So this is the density. So that's not a rate, that's just the density. So centimeters per milligrams, that should be mg per centimeter squared. That would be the unit. And r is the distance out. So at a distance of 2.25 centimeters from the center of the dish, the rate is this a positive answer or not? Yep, both are positive. Is increasing at, and then we can either do that, but you can see it's 4/1/2 or 8, and again that's centimeters per milligram per centimeter squared. That's how fast it's increasing. Part B, such awkward units. It's frustrating that they would actually just give simple units so that you can see if the students know what they're doing. All right, a total mass in milligrams of bacteria in the Petri dish is given by that expression. So it's 2 pi 0 to 4 r times f at r dr. So approximate that value using a right Riemann sum. So a right Riemann sum, how we would do it, and then with the 4 subintervals indicated by the table. So we have 2 pi, we have r, so the radius to begin, so a right Riemann sum, so the radius on the right so it's a right Riemann sum, so the radius on the right, which is 1, times the height on the right, which is 2. Then the next one, the radius on the right, and then the height on the right. And then the next one, the radius and the height on the right. and the radius and the height on the right. A little awkward, right? In terms of the radius and that. So you need the radius value and the y. So you need the x value and the y value, the r and the function, that together on the right side. Part C. Is the approximation an overestimate or an underestimate of the total mass? So to understand if it's an over or under, I need to know if it's increasing or not. So you can see this is increasing going to the right. So because it's increasing and it's a right Riemann sum, so I'm going to just like draw that picture. What does a right Riemann sum look like? You can see that the rectangles are over that amount. So this is an overestimate. Why? Since f at r is increasing with a right Riemann sum. Part D, we're almost there. The density of bacteria of the Petri dish from 1 to 4 is modeled by this function. For what value of k from 1 to 4 is g at k equal to the average value at g at r? So average value is an integration question. So we're going to integrate from 1 to 4. So the average value of g at r is this. And we want to know when that average value is equal for what value of k from there is g at k equal to the average value. So we need to find the average value first, and that answer with your calculator would be 9.875. Then g at k from 1 to 4 is equal to that average value. So take that average value equal to 2 subtract 16 cosine 1.57 square root of, and it's going to be k instead of r to the 3. So the equation that's given in there, but put in k instead, you're going to use your calculator. You're going to go solve, type all that in, comma k. So try with your calculator, type all that in from there and see what k equals. And you see that k equals about 2.497. That's it. Man, that was kind of a whatever first question, right, for the exam that you had to fight through. So it's a little bit awkward, but hopefully you can try to get some points even though it's a little bit awkward. Mr. G Math, over and out. Till next time.